This question is from 2017 Mechanical Engineering paper set 1, question number 43. A machine element has an ultimate strength sigma u of 600 Newton per millimeter square and endurance limit sigma en of 250 Newton per millimeter square. The fatigue curve for the element on a log-log plot is shown below. If the element is to be designed for a finite life of 10,000 cycles, the maximum amplitude of a completely reversed operating stress is dash Newton per millimeter square. Let's find out. We'll start by writing the given things. It's given that ultimate strength sigma u is 600 Newton per millimeter square. Endurance strength or endurance stress is 250 Newton per millimeter square. The number of cycles, let that be T, for which we have to find out the operating stress. It is 10,000, so we can write it as 10 to the power 4 cycles. And let's denote the operating stress that we need to find out by S. So in the given graph that is shown here, we can see that corresponding to the stress value of 0.8 times the ultimate strength has a number of cycles of 10 to the power 3. That means if our system or the structure is being subjected to 10 to the power 3 number of stress cycles, the maximum stress value that it can take or the maximum strength for which it is designed is 0.8 times sigma u, which turns out to be 0.8 times 600, that is 480 Newton per millimeter square. Now similarly, for endurance strength value, we see that the system can operate at 10 to the power 6 number of cycles. So as we increase the number of cycles, we see that the maximum stress that the system can take has reduced and it has come down to endurance stress. And endurance stress is actually, by definition, the value for which a system can take repeated number of cycles without failure. And that number of cycles which this system can take is 10 to the power 6. Now, our system is not subjected to either 10 to the power 6 or 10 to the power 3 cycles, but it is being subjected to 10 to the power 4 number of cycles, that is 10,000 cycles. So, we need to find out what will be the maximum stress that a system can take at this number of stress cycles. So, this 10 to the power 4 will lie somewhere here, 10 to the power 4 cycles. And corresponding to this value, if we want to find out the operating stress, we will just draw a line, and wherever it cuts the graph, y coordinate of that point will give us the operating stress S. But remember that this is a log-log scale. So if these are the number of cycles, it is actually representing log of number of cycles. Even here also, this y-axis is representing log of stress values, whatever are the stress values. Now, AB is a straight line. So, slope of AB will be equal to slope of this small part. Let's denote this point as C. So, we can write that slope of AB is equal to slope of AC. And if we try to find out the slope on this graph, we can write it as, from here, the y coordinates are A and B. So, we have to write log of 480, and this is log to the base 10 minus log to the base 10 of 250 divided by, henceforth we will not write the base 10. It is understood that the base is 10 for all the values. Log of, now the x coordinates. So corresponding to 0.8 sigma u, it is 10 to the power 3. So log 10 to the power 3 minus the other x coordinate is log of 10 to the power 6. This is the slope of line AB. Now we write the slope of line AC. So y coordinates are now 0.8 sigma u and S. So log of 0.8 sigma u minus log S divided by log of 10 to the power 3 minus log of 10 to the power 4. Now let's find out the values and substitute them here. So numerator here turns out to be 0.2833. This can be done directly by substituting all the values in digital calculator. The denominator turns out to be minus 3. Of course, it will be negative, which is equal to log of 480 here is 2.6812 minus log S. S is an unknown, so we'll keep it as it is. and the denominator here is -1. Both sides negative will give us positive, and therefore we can write value of log S will be equal to 2.6812, and this whole term goes to the right hand side, becomes minus of 0.2833 divided by 3. This, when substituted in digital calculator, gives us 2.5868. Now we need to find out S, so we'll do it by S equal to, it will be 10 to the power 2.5868 because the base was 10, and this turns out to be 386.159 Newton per millimeter square. We found out for 3 decimal places. Now let's substitute the answer. Whatever are the decimal places required, you have to round off and substitute those many decimal places. So there is no mention of number of decimal places, so we'll write the complete answer. The maximum amplitude of a completely reversed operating stress for finite cycles of 10,000 is 386.159 Newton per millimeter square. To learn more about fatigue failure of materials, you can refer to the NPTEL video Lecture 24 Part 1, Fatigue Failure of Materials, SN Diagram, Types of Time Varying Loads. This lecture is by Professor Ratnakumar Annabatulla. He is from Department of Mechanical Engineering of IIT Madras. I hope this solution will help you clear your doubt. Thank you.